Hello students, welcome back. Today we are going to explore some powerful properties of definite integrals. Now think of this, when you're solving an exam problem, would you rather spend 10 minutes integrating or 30 seconds applying a shortcut property? That's the magic of properties. They save time, reduce effort, and show the hidden symmetry in mathematics. Let's go through these properties one by one. First, property P0. It says integral from a to b of f of x dx equals integral from a to b of f of t dt. In words, the name of the dummy variable does not matter. Whether we write x or t or y inside, the value of the integral remains the same. This property is basic, but it's the foundation for substitution methods and many simplifications. Next, property P1. It states that integral from a to b of f of x dx equals negative of integral from b to a of f of x dx. So if you flip the order of limits, the sign changes. And a very important corollary, integral from a to a of f of x dx equals 0 because the limits are the same. Geometrically, if you measure the area in the opposite direction, you get the negative of the same value. Now, property P2. This says integral from a to b of f of x dx equals integral from a to c of f of x dx plus integral from c to b of f of x dx. This means we can break an integral into parts by splitting the interval at any point c. It's especially useful when the function is easier to handle in smaller segments or when we are dealing with piecewise functions. Next comes a very interesting property, property P3. It says integral from a to b of f of x dx equals integral from a to b of f of a plus b minus x dx. Here's the idea. If you reflect x across the midpoint of the interval, the area remains unchanged. This symmetry property is extremely helpful for trigonometric integrals and functions that behave nicely when flipped across the midpoint. Now, property P4 and P5. Property P4, integral from 0 to of f of x dx equals integral from 0 to of f of a minus x dx. This is just a special case of P3, but restricted to the interval from 0 to a. Property P5, integral from 0 to 2 of f of x dx equals integral from 0 to of f of x dx plus integral from 0 to of f of 2 minus x dx. These symmetry tricks allow us to fold the interval and evaluate tough integrals quickly. Let's apply one property in a real example. Evaluate integral from 0 to pi of sin³x dx. Let's call it I. By property P4, integral from 0 to pi of f of x dx equals integral from 0 to pi of f of pi minus x dx. Here, f of x equals sin³x. But sin of pi minus x equals sin x, so f of pi minus x equals sin³ again. That means the integral is symmetric. So we can write I equals to times integral from 0 to pi by 2 of sin³x dx. Now compute integral of sin³x dx equals to by 3. Multiply by 2, we get 4 by 3. So the value of the integral is 4 divided by 3. And you can see symmetry cut the work in half. Alright students, let's recap. We learned 6 main properties of definite integrals. P0, the variable of integration is arbitrary. P1, reversing limits changes sign. Same limits give 0. P2, integral over an interval can be split at any point. P3, reflection symmetry across midpoint. P4 and P5, special cases of symmetry on 0a and 0,2a. These properties are not just theory, they are exam gold. They simplify calculations, reveal hidden patterns, and save valuable time. And that's the foundation of properties of definite integrals. In the next video, we'll use these properties to tackle even more advanced integrals with confidence.